Hey, time for your life math and history, and this is part 2 of projectile motion. And just a reminder that I'm gonna get a new iPhone because this phone, the camera's kind of broken. So the videos kind of be a little bit jiggly, but I'll do my best to keep the writing very, very big. So, do you remember from what we did last time? We did this problem about trying to find the different angles in the trajectory of a projectile. And the problem was a soccer player kicks a soccer ball on a level playing field with an initial velocity of 11.3 meters per second on an angle of 35 degrees above the horizontal. Find the flight time, the range, the max altitude or height, and the final velocity of the ball. Last video, we were looking at the flight time and the max altitude. What we're going to do now is we're going to try and solve the range and the final velocity of the ball. So let's start with the range. And just a reminder, we understood that before we solved anything in this video, or before we solved anything in the last video, our initial velocity is 11.3 meters per second, and the degrees is 35. So let's talk about the range. So when we talk about the range, we're talking about how far something goes until it completely hits the ground or completely comes to a fall and crashes. So for the B section for range, here's what we have to do. What we did is we understood the diagrams that velocity is the direction of your speed, your dy is your altitude, and your dx is your range. And we're trying to find what dx is. So when we use trigonometry to find out what your velocity on the x-axis is and the velocity on the y-axis is, we have to use a velocity on the x-axis because we're trying to find the distance of the range. So, how far did the soccer ball player kick the soccer ball before it hits the ground? So what we have to do is an equation. So normally, when you're doing any kind of projectile motion but on a horizontal line, you always have something like dx and dy, where dx is going to have an equation of vx equals dx divided by tx. Velocity equals distance divided by time. On your dy, you usually have your final velocity y, your initial velocity y, your dy, your ay, and your ty. But we don't really want to care about the dy, we want to care about the dx, because we're trying to see how far horizontally the soccer ball goes before it hits the ground. So, we know if we want to try and get dx alone, we got to rearrange this equation around. So we have dx equals vx multiply that by tx. And just so you know, your ty and your tx are the same because you're using the same time in seconds in the same experiment. So here's what's going to happen. From the A section, or the question number A for flight time, we realize that from here to the top is 0.665, and from here to the bottom is another 0.665. So that is going to be our seconds. So our time is going to be 1.33. Our velocity x is going to represent the number and the dotted right over here. So the velocity on x is 9.25 meters per second. So we're going to put 9.25 right there. So our dx is going to equal our vx and our tx. When we do that, we should get an answer of dx. The soccer ball should go 12.25 meters before it hits the ground. Go!
New record!
So we've solve the problem for how far the ball goes before it hits the ground. That is called the range. Now we have to find the final velocity of the ball when it actually hits the ground. So we're going to move on to section number D, the final velocity. The answer for this one is a little bit confusing, but it's actually simpler than you think. So, do you remember when we used this triangle? We understood that our V is going to be the hypotenuse, basically the speed of the ball in a certain direction. Your dy as the height, basically how much altitude the ball has, and dx we've talked about is your range. So what happens here is we know that Vy is going to equal 6.48 from the data right over here. Our V initially, without any axis information, is going to be 11.3. And also, we talked about having 35 degrees below the horizontal. So what happens right here is the answer is literally right in front of you. The answer is going to be that our velocity is going to be 11 meters per second, 35 degrees below the horizontal line. And the reason why we can understand it is not only we calculated all the other information and everything else, but these two pictures kind of help us along. Your dy is always going to push you down. Your dx is going to push you forward towards your range. So yeah, it's kind of easier to show than actually explain it. So that concludes the video. I hope this video has helped you understand part 2 of projectile motion. Thank you for watching Top Fingerless Math Industry. Like and subscribe.